Now we start with the potpourri of my greatest hits. No. Hello. We're here for a panel discussion calling Smarter Vision with Embedded Vision. And I'm quite sure every one of you heard about Embedded Vision. The question is, what did you heard? What did you think Embedded Vision is? And to answer these questions, we have here some experts to discuss it. Will embedded vision make machine vision more straightforward, successful, maybe cheaper? And so we're looking also the influence of embedded vision on different components of machine vision, like cameras, software, smart cameras, processors. And our aim is to reveal which fields the term embedded vision covers and what advantages users will have. Therefore, we have 6 people here. At your left side, it's Mr. Arndt Barker from Basler AG. To his right side, Carsten Strampe from Imago Technologies. Then there's Dr. Olaf Munkelt from MVTec Software. Maurice van der Haar from Advantech. Mr. Richard York from ARM. And last but not least, Andreas Behrens from the SIG AG. And my first question is, of course, what is embedded vision for everyone, for me, for you? Maybe the Basler AG will start?
Does it work? Okay. Yes, we had quite some discussion what embedded vision is all about because we had many different opinions inside the company. We basically came to the conclusion that we define it based on the processor people are using. So we differentiate between PC vision. So if there's a PC architecture, means Intel inside, then it's PC vision. If you use another architecture, most commonly ARM processor, then we call it embedded vision.
Thanks. Mr. Strampe?
Okay, for us, we are mainly in the market, let's say, of embedded machine vision, and our focus is to integrate all the interfaces needed for machine vision, also camera interfaces and all the needed processing power nearby the machine, inside of the machine. And therefore, we support x86 platforms with Windows embedded, but nowadays also ARM processors. And our flagship is an 8-core ARM Cortex-72 to provide huge computing power for all the cameras inside of a machine.
Mm-hmm. And what is embedded vision for software?
Well, I think there are several important factors. One is the form factor. So devices get much smaller. PC-based system still has some dimensions. Number 2 is low power consumption, which is very important. And number 3, we think customers deserve the same power in terms of software on an embedded system than they can enjoy on a PC system.
Thanks.
Yeah, from an Advantech point of view, it's x86. We are an x86 company. We are, of course, continuously looking at the new technology. So ARM is definitely on the scope, but also looking at FPGA technology. So x86 with FPGA technology combined, and also with GPU architecture behind. So visual computing appliance. So you have a front end and a back end, edge to cloud, but not online cloud, on-premise cloud.
Indeed. For us, embedded vision is more of a transformation, taking technologies from other markets such as mobile, such as automotive, and bringing those technologies into what is traditionally a world that's used to embedded PCs. So it's not quite what I've heard. I think it's more transformational than this, because those technologies are typically an order of magnitude lower cost, they're an order of magnitude lower power, and there's a much greater ecosystem around them. So it's about transforming an industry that's PC-based into one that's much more multifaceted.
Sounds fascinating. And what's the point of view from SIG?
I think from SIG's point of view, it has to be first the sensors. SIG is a sensor company, and how to deal with sensors in that embedded vision world. make it smart. Make it smart is the answer, and that is not only the smart sensor as you know from the past, it's also to combine it with some clever ecosystem so that you can embed those sensors easily to your machine.
Thanks. Some points we heard about, but why will embedded vision change or even revolutionize machine vision? What are the most important points for you? Maybe we start once again at the left side.
Yeah, what we see is that if you look at the hardware cost of a vision system today, there's quite a considerable part people have to pay for the processing architecture. And if you exchange the processing architecture, the Intel-based architecture by an embedded architecture, you can reduce the cost quite dramatically. And this goes in tandem with also cost reduction you see on other sides. So an embedded system can be built on a much lower cost point than a PC system. And what we think will happen is that vision will not stay in the factory anymore, but with this cost point, it can really break into markets and application where the technology was previously far too expensive. So for us, embedded is really an enabling technology to go really to more broad market application and really widen the scope of vision technology.
Mr. Strampe?
I agree. You're looking for also different markets, and but on our side, on machine vision, we see really more powerful devices inside of the machine nearby the application, and there we see the advantages of embedded vision with lower power, also more intelligent industrial interfaces. So these aspects are very important.
Mr. Munkelt?
Yeah, I think that first of all, I think it's a transition or transformation process which we see right now. And it also opens up new opportunities in new markets and in new applications. That's one side. We talk about embedded vision. The question is how far is the transformation process or how far the transformation process will go. If I look around here, I see many super duper new line scan cameras delivering 18 kilohertz lines and filling up the main memory within a millisecond. So there are certainly many applications which we still need to address with standard PC-based solutions. Again, the question for me is, what is the ratio? Where will we be in 5 years or in 3 years regarding this ratio?
The next one, Maurice?
Yeah, I agree also with Basler. The technology will become cheaper, but I think it's not only about the front end, because you can make the front end very cost effective. You still need to be able to process it also on the back end side. So I believe in a two-way structure, so cost effective more on the front side and more high performance with GPU side on the back end.
Mr. York?
I think one of the things that I think is most transformational is the applicable markets that embedded vision opens up. As I've said earlier, if you expand the applicability by significantly lowering the cost and lowering the power, you start to apply embedded vision to so many other parallel markets. I was with a company recently doing retail analytics, putting an embedded vision system into lots of locations around a retail site to understand and monitor what those people in that retail site are doing. It opens up tremendous opportunities way beyond what we see here for technologies that are being developed here. So all of this factory technology, inspecting, recognizing objects, think how can I apply that technology to other markets which are adjacent but substantially higher volume and could then offer interesting services as well.
Thanks. Mr. Behrens?
So from the sensor point of view, let me give you a complete other viewpoint. What's about your software? What's about solving the application on an easy way? How to embed it in your machine? So I think there's a need to transform it a little bit to new technology, to make it easy to find ways that integrators can base on a reliable system, on a reliable sensor. You can buy that reliable sensor everywhere in the world. You get services for that sensor, and you get an ecosystem for that sensor, so that you can start off to use that sensor. But instead of the past, the sensor is prepared already with a firmware that is something you know from SIG. Or on the other hand, you have a sensor, you have to program it line by line. So the solution for embedded the sensor into your machine is such an ecosystem like we offer in App Space, that you easily can take off and you embed it easily to your machine.
Is embedded vision really useful for every machine vision application? Or is it maybe for some applications more expensive to use? Does it make sense to use it? For which applications?
I do agree with Mr. Munkelt here that I'm not so sure how big of a drive the classic factory application will have to embed it, because many do have high demands on performance. So I think the transition will not be so quick in the factory side. We are far more looking at the enabler side, because the new markets you described, like the retail, you cannot put a PC in those applications. So the cost point becomes the enabler. And only with this cost point, these markets then can appear. So these markets then will develop the structure, the market structure from the supplier point of view for embedded vision technology. And this will happening, I think, quicker than the transition of the factory side to embedded technology. So we will essentially have three different scenarios. The one is the classic factory market, the second is the transition to embedded in factory, and then the third is the new market. And what we are really looking after is this new market developing. I think there we should be having an eye on.
Everyone's happy? All quite agree? Okay, when we're talking about embedded visions, I'm quite sure we're talking also about new technologies. Which, for example, which new interfaces will be coming for machine vision? Or which new components?
So we see a clear trend out of ideas born in Industry 4.0. Protocols, let me say, for the slow loop, if I like to decide between a fast loop, you typically have to process your data, and your processed data go to a computer or whatever. On the other hand, you like to use the data on complete other ways, and therefore new protocols are born, like MQTT, OPC-UA, and other ones. To support those protocols on that slow loop, you have to do more than easily connecting your camera to a PC. So you have to dig into a complete other world with databases, with big data, and with cloud services. I think that is something we have also to think about with embedded vision.
Mr. Munkelt?
Let me add regarding the standardization point. I think the PC itself is a kind of standard. It's defined by the CPU, by the operating system. We don't have this environment at this point in the embedded vision world. So we still see a diverse set of different CPUs. Today we have ARM here. 10 years ago everybody spoke about TI. And there are several more. On the operating side, today we talk about Linux and different derivatives of Linux. But there are also commercial versions like VxWorks out there. So if we simply take an embedded device today, we have to admit that the complexity of this device today is higher than it is on the PC side. Also, we have to admit that more people are kind of comfortable working on a PC-based solution than there are on an embedded vision solution. So standards is something which is very important, and we have to have a closer look where can we add a benefit. And there are several discussions going on right now to standardize the interface between the sensor and the CPU side. There are also efforts on the side where UPCOA will get a companion, what is called a companion specification, to make it easier to work on the system side. So, and I think we should look inside this matter a little more to avoid a huge space of all different configurations, and then the customer is simply, wow. But he does not know where's the orientation, where's the guideline. So we need actually a kind of a streamlined process in order to make it easier to apply. That would be the key for the success as well.
Yeah, agree. I think the two things I want to add is, if you look at the component market in the factory side today, there was a lot of effort on the standardization between the camera and the processor. We need something similar between the board level products. So kind of board level, chip level between sensor modules and processing modules. So this is one side we are looking in as an industry, and I think the other side is more standardized way between the application and the vision system. So how do you connect your system to the central databases?
Mr. Joa?
Yeah, I think that there's another clear area to me that that could help, and it's a much higher level than what you're talking about, and that's in the software development space. So companies that can enable you to develop on the desktop and then transport that and transpose that down to a much lower cost embedded system would really open up the market, I think, because it would enable you to develop seamlessly in a desktop world, but then deploy it in the mass market with much lower cost embedded systems. So I think there's a real opportunity for people doing software. MVTec clearly doing a very similar thing, developing a desktop version and an embedded version. I think that's a real opportunity for every software company here to have a desktop development environment and a deployed embedded environment that's seamless.
Mr. Schramber?
Yes, related to the interfaces. On the side of chip technology, we see more and more maker of industrial processors for the industrial market, and they combine ARM cores together with, let's say, different special interfaces. One example, a dual core ARM core for the computing power, and an additional RISC processor who has to manage real-time Ethernet field bus. For example, you can integrate your vision system directly into an EtherCAT field bus environment, and everything is integrated on one chip, running under the Linux OS.
Mr. van der Aar?
Yeah, from an Intel perspective, if we look at, they bought Altera, so they make FPGAs. So I think if we look in the far future, we will also see there probably, still an assumption, an integration with now it's a two-step solution, x86 plus FPGA, but probably in the future they will merge the technology all in one, so we can have more powerful and more cost-effective chips.
You're talking about FPGAs, a very powerful instrument, but also a very complex instrument. Who should use it? Who should work with it? Is a machine vision user of today the one who should work with that?
FPGA is hard to program. So is it your standard company? I think it's more software related company that, so Mr. Munkelt maybe can have an answer to that side.
Herr Munkelt, what is the answer?
So first of all, I totally agree. FPGA programming, you forgive me, is a mess. So there are really, if you have 100 people who can program a PC-based system, you may have running Windows. You may have 10 people, just to visualize the magnitude level, 10 people who are comfortable in a Linux environment. If you have probably one who is on an FPGA environment. So for that purpose, we have companies here, actually at the show, exhibitors like Silicon Software, which greatly reduces this complexity because they allow you to use an FPGA, but they supply already a library, so you can actually use them in your system much easier. So that would be one answer to this question. But I also think that we see different hardware architectures right now, and we need them, by the way. This is also interesting probably for you. The machine vision community has never been able to develop a perfect CPU by itself. And I can imagine some architectures where this would really out of a great benefit. Also, this community has never really supplied commercial available CCD octagonal sensors, which would also be much more suitable for precise measurement in this industry. So what I'm saying is we actually need your invention on the CPU side, also on the FPGA side, by the way, in order to bring our own algorithms and to add benefit to the users. In certain applications, we need an FPGA. In other applications, very much okay to work on an ARM-like architecture.
Now I've got a problem. Everyone likes to say something. Mr. Schramber.
just a few additional aspects. First of all, I've never been a programmer. But 20 years ago, I was a FPGA programmer. It was really easy. I like to say, let's say, it's not so difficult to use an FPGA. It's a different method, yes, of programming, and every line of code needs silicon, yes, but it's not so difficult. However, in machine vision, in our hardware, we are using a lot of FPGAs, but mainly for communication functionality. And for functionality which is over a longer time fix. If it comes to image processing, people like to use C++ code. They like to use libraries, a lot of machine vision libraries. And then it becomes more complex and difficult to catch in image processing algorithms and to put that into the FPGA. This is the first point. The second point is, as we are familiar with Altera FPGAs, we also have a look on the combination of Intel and Altera. Yes, and what will happen there. And meanwhile, Altera is more an Intel company. And on the side of Altera, we have also the SoCs like Xilinx, the combination of multi-core ARM processors and FPGA. And Intel as well says, yes, we will use in the future ARM too. So there is a lot of mixtures of technologies. You can use just an SoC with FPGA function with an ARM core inside, in the future with an Intel processor beside. So let's see what will come up. And all of them are addressing the embedded market.
Herr Barge.
Yes, also have some different points of view to bring to the table. I think we need to differentiate between the factory application and the embedded vision application. In a factory application, a typical customer, at least for Basler, is a vision system engineer. The vision system engineer takes the components, plugs them together, and maybe has some colleagues engaging in the software and writing the code. These people normally don't have FPGA experience. So there you have a problem if you have an FPGA programming task at hand. If you go to an embedded vision application, it's different because you're dealing with electronic boards. And if there's customization with the electronic boards, you're talking about electronic integration, people programming ARM devices, connecting memory, and also FPGA is very common in these companies. It's not difficult. It's not so common than PC processing, but I think from a technology point is ripe. And if we talk to OEMs and the embedded vision side, we do find many people able to cope with FPGAs.
Thanks. Mr. York?
Well, so first thing, we're very confident that both Altera and Xilinx will remain faithful to ARM. And they've both been very committed to that, so that's a nice thing. But I see FPGAs as being wonderful tools for dealing with the connectivity mess that you often get in an embedded system. You know, an SoC FPGA's got large processor capabilities, looks just like a conventional processor, but you've got all that flexibility to put different I/O, different connectivity, depending on exactly how you want to adapt your product for different markets, different interfaces. That's the power of these FPGAs, I see. It largely hidden from the end user, but a real boon to system developers that want to cope with a multitude of different markets, multitude of different connectivity options, but one physical product. That's the power I see in an FPGA.
Thanks. Just forget, if you have any questions, just raise your hand and I will come to you, give you the microphone, and you can ask any question you like on these guys. I'm not quite sure if they answer every question, but we'll see. Listening to you, I've got a question. Will machine vision become more easy with embedded vision or more complex? I'm not quite sure after hearing all these arguments.
I think,
Mr. Munkelt?
embedded vision has this kind of closeness to an application. So we heard about this retail application. There are many applications in agriculture or logistics where you put, or security and surveillance, where you potentially would need many vision sensors. So I think if we talk about embedded vision, we always have this kind of application system in mind. So from a user's point of view, it's much more easier because he probably don't need to configure it, he just need to switch on, and then the people are counted correctly while they are walking along an aisle, turning left or right, so we have a left counter and a right counter, and each of these systems is only 30 euro. But to build this, you still need some time and you still need to spend some effort.
Mr. Stramper?
Can fully agree, 100%. It will become, yes, more effort on the application side and more easier on the user side.
Everyone agrees, or Mr. Behrens?
Of course, that's exactly the viewpoint of a sensor. So to encapsulate such an FPGA structure, to hide those arms from the application developer. So he likes to develop an application, not to dig into some FPGA stuff or handling with the operating system. So if you have the functions right in place, maybe also reliable embedded functions from Helken, and you can put all those things together to an ecosystem, and you give this support to an application a programmer. I think that is something and a big step forward to get really embedded systems.
Another question. Which advantages does embedded vision bring along for IPC producers like Advantage?
That's a very good question.
I hope you have an answer.
Let me think about which kind of advantages. Go to the next one. I will think.
Okay. Or what do you think, Mr. Stramper?
We support x86 and Windows Embedded, Linux on x86 and Linux on ARM platforms, full stop. And it's the answer comes from the market, from the customer. Sometimes I would say it's a question of sex appeal of the engineer. Some people really prefer the Windows operating system. They have reasons to use that because they have to integrate a complex database to the image processing application. Other are coming or more younger engineers. They played with a Raspberry Pi board. They are familiar with Linux. They feel it more attractive to work on an ARM platform. So it really depends, and it's a new opportunity also for maker of PC, of industrial PC, to take a look into that market and be active on it.
Mr. Barker?
Yeah, I think the discussion is maybe for me it's a little bit too technical because we are all engineers and we believe decisions are made purely on technology, which I don't think is the case. So why was the Intel-based architectures are so successful in the factory side? The PC was never built for the factory automation market. This market is far too small. The only reason it was used because it was so popular, the most popular processor for the consumers. And if now the most popular processor for the consumers changed over from PC-based over to embedded-based, we can assume what will be the most attractive processor and also on our side if we use the same mechanics. So this is why I think we can talk a lot about technology, but we also need to think of what is becoming mainstream and will be supported by many companies because this will be available and also easy to use later.
Yeah, mainstream is of course one thing, as cost effectiveness. That's what we're all talking about in embedded vision. But yeah, it's I think from an Advantech point of view, we develop a lot of technology. We have more than 4,000 products, so for everyone there is something going from small board to large board with multi-processing, with multi-core technology, also in different form factor boxes. So no matter if you have a large amount of space in your cabinet or if there is in an environment like transportation where you need very small compact housings, there's for everybody, there's a need. And that is what we definitely can provide on a multi-platform. So on Windows, and Windows Embedded, on Linux, not all versions, but the majority, yes.
Everyone else? Here any questions? Not at the moment. So a totally different topic. We're talking about a lot of power. And another word I hear very often is machine learning, deep learning. What about this with the new technologies? Who will be the first? Mr. Munkelt.
Okay.
Mr. York first.
Machine learning, it's in some areas machine learning is transformational. It is certainly transforming certain areas of vision processing. You know, the ability to visually search through Google for cats or dogs or whatever it might be is just incredible. So there is absolutely no doubt in my mind that machine learning in all its various forms is going to change the face of this industry completely. Now, how quickly it will do it, who knows? But it can't be ignored. It absolutely can't be ignored, not least because of the sheer amount of investment going into that space. It's enormous. You know, just look at what the automotive industry is doing. They're investing billions of dollars in machine learning for highly automated driving. That's going to have an impact. It's bound to have an impact.
Mr. Munkelt?
Yeah, now I have to be careful what I'm saying, not to squeeze out the entire time here. Let me add a few comments. Yes, billions of dollars went into this technology already. So driver assistance systems are available since several years already. So these investments have been made. And they have been made to differentiate cats, dogs, grandma, grandpa, people, and everybody. So this is what we would call in machine vision an identification technology. Apart from identification technology, which also includes barcode and data code reading, by the way, and this is not a subject of deep learning or machine learning, this is simply straightforward technology. We also have topics like measuring in 1D, in 2D, in 3D. Metric measurements, meaning to have a camera calibration in place, means to cover many different technologies. And all these is not part of deep learning. So it's not the overall which gets us the solution, the answer to everything, the 42 problem, so to speak. It's one more step in the direction of identifying objects. And we should also be careful differentiating between training and actually identifying, because the training process in deep learning is super duper time consuming and super duper computational expensive. You can parallelize this, but typically in order to train these nets you need days and weeks and weeks and months. So it's a big point as far as we can see this. And last not least, once you have done this, execution time may be very quick. So there would be more to say, but I stop here.
We have time after that. Another statement to deep learning?
No?
Oh yes, there's one.
Well, I was just say, I think it's the fusion of machine learning and conventional vision algorithms that's certainly the key. If you can bring those two domains together successfully, that will be really when it'll be very powerful. I absolutely agree. There is no substitute for many of the fundamental vision algorithms that people have developed over the decades. Having said that, those that ignore machine learning do that at their peril, I think.
Totally agree. And just as an example, it's a classification technology, and one very popular application in machine vision, and also I'm sure in an embedded vision system, is to read characters. Very simple, OCR. So we at MVTec, we use deep learning to improve OCR. So we actually have used it, and it has a benefit. Yes, it gets us a few more percent of recognition rate, which is critical in a machine vision environment.
So, but what do you think about the technology? Who is going to be then the key player? Is it the visual computing appliance technology, the GPU? Or is it the FPGA? Or how do you see it? Because we see with deep learning, it's on the back-end side. So the embedded vision on the front end is capturing images, and the back-end side is learning from what it's capturing, and then it needs to start processing. So this part, from an Advantech point of view, is on the GPU side. Do you see the same? The only problem that I see from a GPU point of view is that the market leader in GPUs we all know is NVIDIA. But how good is the support for us in the embedded world of NVIDIA? Because they're more consumer related. They have a professional line.
That's what I mean. We get more complexity. We get more computational architectures. And yes, you use GPUs for deep learning. And we don't know what will happen in 3 years. Maybe in 2 years we're sitting here and we see, oh, there's another super duper algorithm and we need another super duper architecture to run it. So I think it has this different view. If we have a technology which adds value to our existing customers and to our new customers, then we will use it no matter what it is. That's why I said that we are living on what you guys are doing, what GPU guys are doing. If it adds a value, we will simply use it.
We're not standing still.
We are not standing still, exactly.
Okay. Next question. If embedded vision is becoming so fast, so cheap, who needs still an IPC in the future? Do you think there's a market for your products?
Everybody. Otherwise, Advantech would be bankrupt, and I don't think that will happen very quickly. So I think there will always be IPC. Even if there is embedded vision for the pre-processing part, I think there's always something in the back-end side. And there are still applications that require faster processing, maybe a two-step solution with FPGA or with a GPU. So I think not everything can be done with it, so the IPC will still exist. Maybe in a different form factor, it could be, more smaller, more compact, but it will definitely exist.
Mr. Stramba, I'm quite sure you have an opinion to that question.
First of all, I can agree. What I see on the IPC side is that the engineers, they have more and more different tasks, all of them realized on the IPC, not only vision. Yes, different tasks, database, communication, industry 4.0, whatever. Sometimes they try to put too many tasks on the IPC, but this is a different aspect. But I don't believe that the IPC will decrease only because of embedded vision.
Mr. Behrens?
Yeah, what we mention is exactly, Carsten, what you pointed out, sensor fusion, combining different sensors, not only based on vision technology, also using LiDAR sensors, or to combine it with simply an encoder for the driving vehicle you are controlling now. That is exactly what I think. There's a big step forward to combine those sensors, and there's a need for computing power, for sensor integration machines. That is what we call those things, but you are right. There's definitely a need.
Mr. York?
Yeah, again, my expertise is often in some of these parallel markets, and in the automotive world, this concept of fusing multiple sensors together absolutely is transformational, because it becomes much more than the sum of the parts. So yes, I agree, and that in of itself pushes the computation up, and we are not standing still in that regard, and you'll see a lot more from us over the coming years in making our CPUs even more friendly to the vision space than they are today.
Mr. Barker?
I do see that things will develop in parallel. We compare that a little bit to other trends we've seen in the past, for example, with a frame grabber or without a frame grabber. So what you can see is that once you have technologies which can take the frame grabber out, they're far more cost effective and they're appealing to a large majority of customers. Nevertheless, you have a certain group of customers who are performance driven and who stay on the high technology. So, and I think the transition over to embedded with regard to factory will be slow. It will develop first in other markets and then slowly come back to the factory side. And then the growth of embedded technology will be higher than IPCs, up to a point that you might see a shrinking market. But you're really talking about very long-term developments here. So not anytime soon.
Everyone's smiling, but no one likes to say any more thing. Okay. Just another question to you. How do camera manufacturers benefit from embedded vision? At first, I think a camera and embedded vision? Don't know.
Yes, we believe we do. So maybe give you two extremes. We have a camera like our compact camera is sold in the factory market. And you go to the very extreme, we talked about automotive, you can take another example, which is Microsoft with their Kinect device. There's an embedded vision system in there. So can you imagine Microsoft ever buys our camera, put it in there? No way. And there's a market in between, like the classical component market and these very high volume applications. And we believe that also as a camera supplier, you can find a role supplying camera modules, which then can be connected to embedded processing. So for us, it's an interesting market, yes.
Thanks. We're talking a lot about new markets at the beginning. Maybe we could name some examples for that. What do you think will be the new markets for embedded vision?
A very interesting one, which is already living, is for example, retail. Retail, for the most part, is embedded vision technology. Also from a cost point of view, very application specific. You don't see a general purpose solution. It's really a single purpose solutions you normally see there.
Other markets?
I think transportation, security and surveillance, that kind of markets will definitely going to use this technology. Even though, if you look on the security side, the cost factor of a camera is always impacting. We have companies like inVISION here on the booth, so they're also dropping their price quite rapidly. But the security in Europe, but all over the world, becomes much more important. And I think we need to filter the data that comes from a standard camera. And we can do that with an industrial camera.
Other markets? Mr. Behrens?
Of course, closely related to identification. The bold thing, track and trace and inline inspection. I think that is something you could not order exactly to one market. You can use it in automotive and other markets, similar markets. So I think there will be definitely more embedded systems inside those markets.
Bad question. If we're talking about more and more intelligence into some products, will be the smartphone or a tablet be the machine vision system of the future? Do we need these products here anymore, or will it all be done with the next iPhone? Mr. Stramber?
Very easy. It's a joke. It's just because why? A tablet or a smartphone. Of course, there is computing power inside, and we have an operating system based on Linux. But it's a commercial product. Today, we have discussions with our customers using Intel processors about lifetime, longer than 5 years. So should not be used with a commercial product. They are not able to run in a 24/7 mode, yes, in industrial environment. And finally, these devices do not the interfaces we are looking for. So let's say the question is old, because in former times we have been able to use a smartphone, and I remember some exhibitions back you used a Nokia smartphone to run Helken embedded. But I think for the industrial vision market, it's not the solution.
Yeah, one more comment with this. Yes, we have to differentiate between B2C and B2B businesses. In the B2C business, we have other restrictions, requirements than we do have in the B2B sector. In the B2B sector, we need reliability. I just want to give you one example. Several years ago, we had a big discussion regarding GPUs and how we can use the power of a GPU in an imaging system. That created a big hype, so to speak. And so everybody in the community, in the machine vision community, looked inside this matter and found that, oh, there are several algorithms which we can speed up on a GPU, so let's do it. Well, that was one story. The other story is that what is the price tag of a GPU system which really delivers this computational power? Most customers simply found out that they would have to pay twice for their CPU side of the imaging system in order to get to this point. And then they simply balance, is it worth to pay twice the price regarding the performance which I get? And I can tell you from our experience, 80% of the customer voted no. So we have to keep in mind that we have restrictions in different markets, different needs. And I also see this here. Although we see many fancy algorithms on a mobile phone, I really have to agree. I'm using them by myself, but we have requirements which we have to fulfill. If automobile industry says you have to deliver 10 years the same thing with the same interface, you have to do it. If you don't do it, you will not get the job.
Mr. Behrens?
Of course, such a smartphone is not able to cover all the needs from the industrial applications. On the other hand, we see some trends that those phones will be used for identification purposes. It's very easy to build up an app. You can easily handle it, and everybody knows how to deal with those things. And there are really some shares or some market points, and they will develop that customer use more and more those smartphones. On the other hand, I think it's a good situation for us here. We can use those smartphones as a, let me say, terminal, as an interface, as capabilities like Wi-Fi, Bluetooth. Everything is there. Everybody can handle it. And it's easily to bring up an web service on such a smartphone. So on one hand, of course, they cannot substitute industrial vision. On the other hand, I think it's a good opportunity for all of us to use them.
Mr. York?
Yeah, several things I think it's worth mentioning about the consumer product space. The most obvious one for me is that vision is starting to be an interesting next wave of innovation around phones and tablets. The ability to sense the world around your phone, provide augmented reality, all of these things actually is the next wave of innovation in smartphones. So are you going to use phones directly? No, you're not. But you absolutely are going to take advantage of the innovation in the phone industry. The other area you're going to take advantage of is those underlying SoCs that the chip vendors, the likes of Qualcomm, are building. They would love to find parallel markets for those devices in the embedded space. And we see that today already, that mobile phone chipsets are being produced in industrial grade devices, industrial grade packages that can be repurposed. So there's huge benefit from the technology development that goes on in the consumer space, I believe.
Thanks. As time is running out, are there any questions here from the audience? No one. So I still have a last question to every one of you. We talked a lot about what machine vision can learn from embedded vision. On the other side, what can embedded vision learn maybe from machine vision?
Yeah, I think embedded vision does not have the vision portion yet. So embedded comes from embedded people having experience with electronic design, software design. The whole vision part is missing. So the way how to handle light, optics, transform that into an image, and then deal with that image. I think embedded vision can learn a lot from what has been developed in machine vision already. And also what I think is interesting is the component type of structure which has been developed in machine vision, helping customers to combine different sensors with different processors, trying to deal with the variety of different applications. So I think this can also be interesting concept for embedded vision.
Thanks. Mr. Strampe?
Embedded vision. Sometimes maybe they can learn about reliability from machine vision in all aspects, hardware, firmware, libraries, the whole system. And this is one aspect. The other one is we also exhibit at the embedded exhibition in Nuremberg. So we have a lot of contact to these people thinking about embedded vision systems. Sometimes they start from zero to design an embedded vision system, which is already available in machine vision. So the idea is to each one can learn from the other part, but often there are new developments of already existing systems in machine vision.
Thanks. Mr. Munkelt?
Yeah, from the algorithm side, I would say that there are plenty of algorithms which have been proved for many years, for decades in the machine vision world. Embedded vision so far I see very much focused on the most popular technologies. They have done great achievements with support from great and big companies. Here we have developed a very distinct technology over decades, and I think if they would look a little inside this, they can also make a real machine vision application on an embedded system much quicker.
Mr. van der Haar?
Yeah, from a system point of view, I think the most important is the longevity, the revision control that we offer to you as a client to make it stable. I think that is one of the most important parts from a system point of view.
Thanks. Mr. York?
I'm not sure I have a huge amount to add to that, although one area that we want to do is learn broadly from the whole industry, both embedded vision and machine vision, so that we can do a much better job of developing what we build, because we are a key enabling factor to an awful lot of what's going on here. So actually, one thing I would like to do is learn from everybody here, and if you have feedback and you have requests and you have things that you think could be done much better from an embedded processing perspective, please come and talk to us.
Thanks. Mr. Behrens?
Yeah. So if we get the same reliability, the same good things we know from the base vision things, so if we get them all in place and we can rely on it and we can get the right services for it, then embedded vision could be a good deal. On the other hand, if this will not take place, then the customer will decide what is the right way going on there.
Thanks a lot. That was it. Our time is definitely running out. The next one, I'm quite sure, will be here and will be in a few seconds here. So have a nice day here at the Vision Fair, and thank you.